One good day, Algebra 7. We are going over CO58, which is using what's called the discriminant to gain information about a parabola's x-intercepts. So far, this unit has mostly been, what can we figure out about a parabola? It all started with CO53 when we talked about the minimum and maximum points and the axis of symmetry and all that. We then went to graphing them. We went to solving them. Last objective 56 was using the x-intercepts to find the equation. This is kind of a nice summary of a lot of that stuff. Most of this is review as far as the direction that it opens, the vertex, and the y-intercept. All that's the same thing from PO54. Then the new piece today is using the discriminant, which again, it's information about the x-intercepts. What the discriminant does is it tells us how many x-intercepts a parabola has. Not what they are, but just how many. And if you remember, back from PO55, there were three options for how many x-intercepts a parabola could have. 2, 1, or 0. Okay? And so the discriminant itself, and this is a key point, highly recommended, ends up on a help sheet for you. The discriminant is b squared minus 4ac. B squared minus 4ac. And those variables a, b, and c, of course, come from ax squared plus bx plus c, just like we saw in PO54 with the vertex and things like that. Okay. When we get to PO59, which is coming up next, you'll recognize this as part of the quadratic formula. But isolated, just by itself, it's called the discriminant, and it tells us how many x-intercepts a parabola has. So if you calculate this, and the discriminant is positive, it means the parabola has 2 x-intercepts. Doesn't tell you about anything where they are, but just that it has 2 of them. Okay? If you evaluate the discriminant and it equals 0, it means that there is 1 x-intercept. And someone with a good memory, remind us what it means for a parabola to have 1 x-intercept. How is that possible? If what goes down comes back up or what goes up comes back down, how can it only cross the x-axis one time? Miranda? If the vertex is on the x-axis. Okay? If your discriminant is negative, it means that there are no x-intercepts. It does not cross the x-axis. Okay? So what we're basically going to talk about today is, given an equation, without graphing it, we're going to determine which direction it opens, what the vertex is, the y-intercept, and how many x-intercepts it has. Isn't that fantastic? It's like the Fantastic Four things that we can figure out. Fantastic Four. Okay? We have the Magnificent Seven in our math packets and the Fantastic Four things here. Okay, so let's start with 3x squared minus 6x plus 7. There are 2 things that we can calculate. I shouldn't say even calculate. 2 things we can determine without doing any math at all, really. The direction and the y-intercept. Which direction does this parabola open? Joey? Up. And you know that because the a term is positive. Okay. What is the y-intercept of this parabola? Thomas. And you know that because the c term is 7. Okay. The other 2 things, they require some formulas and some calculations and calculators and things like that. But to calculate the vertex, if you recall, it's an ordered pair, and the x value comes from the formula negative b over 2a. That should definitely end up on a help sheet. Okay. We have negative b over 2a. We're now introducing b squared for ac. The quadratic formula is a total beast in and of itself. So all these formulas, put them on a help sheet because they all use the same variables. It's easy to mix them up. Negative b over 2a, in this case, since our b value is a negative 6, it's going to be a positive 6 in the formula, since those negative signs cancel out. And then 2 times a is going to be 2 times 3. We get 6 over 6, which is a vertex x value of 1. Okay. And again, this comes straight out of PO54. So if you find that you need to review this a little bit, that's where you would look. How do we get the y value of the vertex now? We found x, that's half of it. How do we get the y? Drew?
Plug your x value in.
Right, we go back to the original equation and we plug x in. So 3x squared is going to be 3 times 1 squared minus 6 times 1 plus 7. And practice putting that in your calculator now, because if you wait until the test to actually put this stuff in the calculator, if you do it wrong, then you're going to get wrong answers and it's not going to be very good for you. So 3 times 1 squared minus 6 times 1 plus 7. What do we get? Peter?
4.
Do we have a second on that?
Yeah.
4 is correct. If you didn't get 4, go back and make sure you squared the first x, that you subtracted 6 times 1. You know, maybe kind of see where you made your mistake. All right, now for the new part. All this is review. The new part, the number of x-intercepts, we're using the discriminant, which is b squared minus 4 times a times c, to determine this. And so we're just going to plug values in. Our b value is a -6. So -6 squared, notice my use of parentheses here, squaring a negative, minus 4 times a, which is 3, times c, which is 7. Okay? Without doing any calculations in your calculator, since we really don't care about what the answer is, we only care about the sign of it. Is it going to be a positive number, 0, or a negative? Who can predict the sign of our answer here without doing any calculations, just based on what we have? Blake? Why?
Because negative. That should be negative.
Why?
Because -6 squared is 36.
Okay.
The negative 4 multiplying will get you to negative number, and the negative number times positive number is negative number.
Okay. And well, it kind of stepping off of what Blake said, we know that -6 squared is 36. We can do that mentally. Okay. And then we might not be able to do -4 times 3 times 7 mentally, but we can estimate that that's going to be greater than 36, right? So we're going to be subtracting a number larger than 36 from 36. That guarantees ourselves a negative answer. If you actually calculate it out, 4 times 3 times 7 is 84. So we get 36 minus 84, okay, which gives us a negative answer. And that's really all we care about. The actual number that this equals doesn't really mean anything. It's the sign. The fact that the sign of the number is negative tells us how many x-intercepts does this parabola have. Look back at your notes, like 2 inches up the page. The fact that the discriminant equals a negative number, 36 minus 84 is a negative number. What does that tell us about the number of x-intercepts it has? Sepa? It's got 0. Okay? That's what the discriminant tells us, how many it has. Let's look at the third one, just to give myself more space to write here. 9x squared minus 6x plus 1 equals 0. What can you tell me about the direction of the parabola and its y-intercept? Morgan? We're on the third one. It's going up because that a term is positive. And what is the y-intercept? Carolyn? Positive 1, 0, 1. Okay. Now the fun part starts, the calculation here. To find that vertex, we're looking at negative b over 2a, which our b value is a -6 again. Well, that's not very much variety. So positive 6 is our numerator, and then 2 times 9 in the denominator, which gives us 6/18, which simplifies to be 1/3. Fractions are always kind of annoying. This is one more thing to deal with, right? But it's not as bad as when we had to graph a vertex with the fraction, because we actually had to find that value on the coordinate plane. Here, we just have to know how to use 1/3 in our calculator. And who remembers the 2 ways to input a fraction into a calculator? There's 2 methods that we've gone over. William? The first way is that ABC key. So 1 and then ABC 3 gives you something that looks like this. That tells your calculator this is the fraction 1/3. What's the other way? Like my calculator here doesn't have that ABC key. So how would I do it on a calculator, or another option for you, Carolyn?
You just put 1 divided by 3.
Right. In parentheses, put 1 divided by 3. Your calculator reads that as 1 divided by 3, but that's what the fraction 1/3 is anyway. So you're either, and the other difference here is if you put it in as a fraction using the ABC key, the answer that it gives you will be in fraction form, if that matters. If you give it to it as 1 divided by 3, the answer that you get will be in decimal form. So depending on whether you want a fraction or a decimal as an output, you can determine whether you want to use the ABC key or just 1 divided by 3. Anyway, plugging this in, let me use a different color so I don't get too confused here. We've got 9 times 1/3 squared minus 6 times 1/3 plus 1. And this one works out as a whole number anyway, or an integer value anyway, so we don't have to worry about fraction or decimal. But what do we come up with? Who's got the, Mackie? 0? Do we have a second on that? Okay, 0. If you don't get 0, take a look at y. Are you inputting things correctly? Anybody having any issues that you want to talk about? Okay. Now, the last part, the new part, the number of x-intercepts. Do we technically have to do anything here? So why not? What's already 0? The vertex has a y value of 0, meaning what? Not that, but a y value of 0 in an ordered pair means what, Thomas? It's touching the x-axis. It's on the x-axis. This being an x-intercept here, where the vertex is, if the vertex is on the x-axis, then how many x-intercepts does this parabola have? It's going to have 1. But because we are mathematicians and we like to do this stuff, we're going to do it anyway because it's new and practice is good. So number of x-intercepts, we've got our discriminant b squared minus 4 times a times c. Our b value is -6. So again, notice my use of parentheses. And so we're squaring that and we're multiplying that by 4 times our a value, which is 9, times our c value, which is 1. So -6 squared minus 4 times 9 times 1. You can probably mentally see that -6 squared is 36. And 4 times 9 times 1 is also 36. And 36 minus 36 equals 0. So if nothing else here, the fact that the discriminant tells us we only have 1 x-intercept verifies our vertex is correct because those two things match, right? If we had gotten a vertex on the x-axis, but then something other than 1 from the discriminant, then we'd be in some trouble. But everything looks good. Okay? Questions on this, particularly the discriminant piece? The other 3 things are from CO54, but the discriminant being new. Anything you're wondering? Blake?
Somehow on the first one, and on the third one, I'm getting like, for the vertex like 110. I don't know how I got there.
I'll come check and see what you type it into your calculator and then leave the display up so I can take a look at it. Anything else? Yeah. When you plug the discriminant in?
Like, when you wrote it in red, I plugged that in.
Oh, type it in again and leave the display up, and I'll come around and take a look and see what's going on. Anything else? Okay, your homework for tomorrow is to finish these other 4. Find the direction, calculate the vertex, the y-intercept, and the number of x-intercepts. You do not need to do the second page for tomorrow. So just this first page of CO58 homework for tomorrow. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? All right, that's how you math.